Bismillah ar-Rahman ar-Rahim. Today, inshallah, I'd like to talk about Chapter 10 material, and specifically, I'd like to talk about quadratic functions. So, this material is more or less an extrapolation of the stuff that we've been doing in Chapter 9. So, before I even talk about this, I'd like to review some of that material, inshallah. First, I just want you to appreciate that this is a monomial. This is a binomial. And this is a trinomial. And if you keep going like this, let's say if I have like 5x to the 7th plus 6x to the 6th plus 3x to the 5th minus 4x to the 4th minus x cubed plus 4x squared minus x plus 6. This is a polynomial. Polynomial. So this is a polynomial. So this is a monomial, binomial, trinomial, and a polynomial, right? So many terms, right? Polynomials. Now, there are a few terms associated with polynomials that we have to appreciate. For example, I have 3x to the cubed minus 4x squared minus 6x plus 5. Okay, this is a polynomial. One of the things that you appreciate that when you write polynomial, it must have its mathematical good manners to write them in decreasing order of the powers. Decreasing order of exponents. So 3, 2, 1, x to the 0. So decreasing order of exponents. That's just mustahab, the mathematical good manners, so to speak. And the highest exponent, okay, the highest exponent is the degree of the polynomial. So this is a third degree polynomial. This one, 13x squared minus 5, this is a second degree polynomial. So the highest degree is the degree of the polynomial. See, each individual term has its own degree. This is a 1 degree, second degree, third, but the polynomial is known by its degree, highest degree. That's it. This is a third degree polynomial. Okay? These are coefficients. So these are coefficients. The last term, this one that's all by itself, that's called the constant term. Okay? So each one of this is called a term. That's a term. That's a term. That's a term. That's a term. So this has 4 terms. Okay? And the last term, without the variable, that's the constant term. Okay? Now, again, just as I want to review, these are just terminology. So each of these is called a term. So in this polynomial, there are 4 terms. Now, I'm going to write another one, 3x cubed minus 4x squared. This is also a polynomial. In this polynomial, there are only 2 terms, where there are 4. Now I just wrote those 2 down. These are these are coefficients, the numbers before the variable. These are coefficients. Okay? And the coefficient of the highest term is called the leading coefficient. Right? And the variable with the highest exponent that gives you the degree of the polynomial. So this is a third degree polynomial, this one. This one is also a third degree polynomial. They're both third degree polynomial. But this third degree polynomial has 2 terms, and this third degree polynomial has 4 terms. Correct? Now, watch this. This is a first degree polynomial. This is a second degree polynomial. Correct? You agree with that? This is a second degree polynomial. Okay? Now, second degree polynomials are special. Okay? These are called quadratics. They're given a special name, quadratic. Okay? So, this is a quadratic expression. Okay? X squared plus 2x plus 3 equals, 5. This is a quadratic equation. And y equals x squared plus 2x plus 3. This is a quadratic function. Okay? Now again, watch. X squared plus 2x plus 3. It's a quadratic expression. X squared plus 2x plus 3 equals 0. This is a quadratic equation. And then y equals x squared plus 2x plus 3. Now this is a quadratic function. Do you understand? So, quadratic expression, equation, and a function. Here, you solve for x, you get 2 answers at most, right? Here, there's nothing to solve. It's not even an equation. This is a function. You can't solve this, there's no 2 answers. It's a function, okay? So, y equals mx plus b. This is a line, okay? So, if I give you f of x equals 2x plus 3, this is what? This is a linear function, correct? And if I give you f of x equals 2x squared plus 3x plus 5, this is a quadratic function. Okay? Now, this, if you were curious, 2x cubed plus 5, the third degree, okay, is a tertiary function. Okay? And this, if you're curious, an example of it, quartic function for quartic. Okay? So linear, quadratic, tertiary, quartic. I don't know if the other ones have any names. If they do, I do not know. Now, it's very important to understand a second degree polynomial is a quadratic polynomial. The second degree function is a quadratic function. Now, this is what we've been doing before. We've been factoring, for example, quadratic expression. And previously you factored this like this, right? And previously you have solved quadratic equations here. So you did this. And then you said x is equal to -3. x is equal to -2, and you got 2 answers. So previously we have worked with quadratic expressions and quadratic equations. Here we're going to learn about quadratic functions. What is that all about, right? Now look, y equals x squared plus 5x plus 6. This is a quadratic function. Another way of writing the same thing is f of x equals x squared plus 5x plus 6. Now, if you've forgotten this terminology, this is another way of writing. It makes things life easier. If I say, what is f of 0? This means, what is the value of the function when x is 0? So when you substitute 0 for x, so you get 0 squared plus 5 times 0 plus 6. So that's going to be 6. And if I say f of 1, that means what's the value of the function when x is 1? That would be 1 squared plus 5 times 1 plus 6. That's 1 plus 5. That's 6 plus 6 is 12. Etc. If say f of 2, you would substitute 2 squared plus 5 times 2 is 10 plus 6. That's 4 plus 10 is 14 plus 6 is 20. Okay? So, like that. So this is a quadratic function. Now, we had before 3 ways of writing a line. It's ax plus by equals c. That's the standard form. Y equals mx plus b. That was the slope-intercept form. And then y minus y1 equals slope times x minus x1. This was the point-slope form. So these were 3 forms of writing a linear function. Right? Those are 3. Similarly, there are many ways of writing a quadratic function. We have those for lines, and to be fair to the quadratics, there are also several ways. The first way that we're going to explore is the standard form, okay? That looks like this. Y equals ax squared plus bx plus c. Okay? In the standard form, you must understand a and b and c are numbers, are constants. Okay? In this case, a is 1, b is 5, and c is 6. And the variables are over here. That's the standard form. So again, the standard form of a quadratic function is y equals ax squared plus bx plus c. This you must know. So this is the standard form. Now, you know, if I gave you this, y equals 2x plus 3. If I asked you to graph that, it would be pretty easy for you. Y-intercept is 3, slope is 2, go to 3 and go up to that 1 and you graphed it. You have graphed a line. You know it looks like a line, correct? So, but what does this look like? Okay? What does that graph look like? Okay, that's what we're going to try to appreciate in this chapter. But we're going to start slow. Now the parent graph, y equals x squared. Now parent graph is the most fundamental, the most basic, the most easiest, simplest graph that is representative of that class of functions, right? So this is a parent graph of quadratic functions, or parent equation, or parent function. So this is the parent function. Okay, in other words, this y equals x, which is a quadratic function, y equals x squared plus 0x plus 0. In this case, b and c are 0, a is 1, right? So, because y equals ax squared plus bx plus c, that's the standard form. So this is a quadratic function. The parent function, or the parent graph, is a representative. In other words, if you understand the parent function, you can understand a whole host of other quadratic functions. Okay, so this is the most basic of the quadratic functions. So we must endeavor to try to understand this thoroughly. So that's what we're going to do. So the first question is how does this look like? What's the graph of y equals x squared? Okay, so let's try to graph this. All right, so let's try to graph this. Okay, I'm going to put here x-axis here, and then the y-axis over here. Okay, so let's make a table. Let's make a table. So this is going to be x and y, this input-output domain range. So let's pick some values, y'all. So 0. All right. So when x is 0, okay, and if you allow me, I'm going to say f of x0 because this makes life so much easier. So f of 0 is what? When you plug in 0 for x, it's going to be, and 0 squared is 0. No surprise there. So f of 0 is 0. So let's do 1, 2, 3, minus 1, minus 2, minus 3. Okay? So f of 1, what's the value of the function when x is 1? Okay? When you plug 1 in there, you get 1 squared is 1. That's easy enough. Now, f of 2 is when you plug in 2 over there, you get 4. 3 in there, you get 9. F of negative 1 is when you plug in negative 1 over there. Negative 1 squared is 1. F of negative 2 squared is 4. When you plug in negative 3 over here, you get 9. Negative 3 squared is 9. Now, even look at this, even before you graph this, look at this. 0, 1, 4, 9, 0, 1, 4, 9. So, okay, let's draw. So 0, 0 is right here. Okay. So when x is 1, y is 1. Okay, that's good. When x is 2, it is 4, approximately over there. Okay? There's blue here. Blue here. Brighter. When x is 3, it is 9. It's 4, it's 8, it's about 9. Close enough. That's it. When x is negative 1, it is 1. When x is negative 2, it's 4. When x is negative 3, it is, like over here, 9. So it's symmetrical. And if you were to plot a whole bunch of points, if you were to do more of this, you would get something like this. Okay, see that? This would be the graph of y equals x squared. This is, of course, a parabola. This graph is a parabola. So we try to graph this here. Y equals x, which is that's a parabola. Now, parabola has some features that we have to understand, okay? So let's try to understand a parabola. So, again, y equals x squared is the parent graph for quadratic functions. Y equals x squared is a parent graph for quadratic functions. And the quadratic functions, all quadratic functions, are parabolas. Okay? Y equals x squared. All of them are parabolas. Now, this point right here, the turning point right here, that point is called the vertex of the parabola. Okay? A vertex has an ordered pair. Okay? You can call it whatever you want. I actually call it Vx and Vy. The x coordinate of the vertex, the y coordinate of the vertex. Many books call it H and K, and that's okay too. And then I found this to be more intuitive and easy to work with. So the vertex has an ordered pair, and that ordered pair is called the Vx, Vy. Okay, the x coordinate of the vertex, the y coordinate of the vertex. Okay. Now, the parabolas can be like this, and parabolas can be upside down too. In this case, this point here, the turning point, right? That's called the vertex, and it will have its own ordered pair Vx, Vy, the x coordinate of the vertex, and the y coordinate of the vertex. Okay? Now, so that's the vertex. So, and every parabola also has a line of symmetry. In other words, it's symmetrical, like this. It's half the graph is here, half the graph is here. Okay? This is called the axis of symmetry. Now, if the parabola is like this, if the parabola like this, the axis of symmetry is going to be a vertical line, right? It's going to be x equals something, right? The axis of symmetry is going to be a vertical line. For example, they don't have to be centered around the origin, see? I could have a parabola that looks like over here, okay? Right? Then the axis of symmetry would be here. So it's still going to be a vertical line. And you know the equations of all vertical lines are x equals something. And if parabola like this, the equation of the vertical line is going to be x equals what? It's going to be the same. What's this? This is the vertex, right? So the vertex has Vx and Vy, right? So the equation of the axis of symmetry is going to be x equals Vx. Okay, right? Because it goes through the vertex, doesn't it? The axis of symmetry goes to the vertex, right? That's the axis of symmetry. Okay, so we learned that. Now, as I have suggested, there are different types of parabolas. Here, watch this. This is one type of parabola, and this is another type of a parabola. So this parabola, this looks like a U, and this looks like an N, right? The first one's a U. So this one will have the minimum value, and this one will have a maximum value. Okay? So parabolas that look like U will have this vertex is going to be the minimum value. And parabolas that look like U, let me do this in separate graphs. Oh. So the parabola that looks like a U, this parabola's vertex will be the minimum value, right? And for parabola that looks like an N, it's like this type of parabola, the vertex will represent the maximum value. I'm not going to elaborate on that in the future, but I just wanted you to appreciate that the vertex is going to represent either the minimum value of the parabola or the maximum value of the parabola. Okay. Now let's go back. So I have suggested to you y equals x squared is the parent graph of all quadratic functions, right? So this is y equals x squared. You have to know this. The vertex of this is 0, 0. That's the vertex. Got it? The axis of symmetry of this graph is x going to equal to 0. That's the axis of symmetry. It's this vertical line over here. Got it? Okay. So this is the parent graph. Now, if y equals x squared looks like that, what do you think y equals negative x squared is going to look like? How's this graph going to look like? And if you said it's going to be a mirror image like this, you would be correct. In that case, you can give yourself 100 points. And if you didn't say that, you can give yourself 100 points anyways for trying. So, y equals negative x squared. Now, you follow that. That's going to look like this. Okay? Oops, let me just... Now, if I give you this, this is the parent graph. Y equals, these are obviously, artistic renditions. They're not exact. Huh? Y equals x squared. If that's the parent graph, what does this look like? Y equals x squared plus 2. What is this going to look like? It's going to be this graph moved up 2, isn't it? You understand? Correct? That's going to be y equals x squared plus 2. Let's try this. So this is y equals x squared. Okay? This is y equals x squared. Let's graph this one. Y equals, let's do this one. Negative x squared. See? There's that. Alright, so how about, let's do y equals x squared plus 2. I'm going to add 2. What's this? 2. Do you understand? It's the vertical, so the whole graph is going to be moved up. Okay. Now, what if I put over here, let me ask you this. Let me ask you this. Would you, assuming you wanted to get paid and you like to make money so you can give some of it to charity, would you rather be paid y equals x squared, or would you rather be paid y equals 5 times x squared? Yes, you'd rather be paid 5 times 5x squared, right? So what's the difference between this graph and this graph? What's the difference between y equals x squared and 5x squared? I'm going to put a 5 there. What do you think it's going to look like? Huh? Total. See, that's the blue graph. There's the 5x squared. This is y equals x squared, the parent graph. The y equals 5x squared. It's going to go up faster, see? It's going to go up faster, right? It's going to have a higher slope, so to speak. It's going to go up faster. Alright, now what if I put a negative 5x squared here? It's going to be this blue graph flipped down, right? Ta-da. You see that? Now, so here's y equals x. Now, what if, on the other hand, okay, if I ask you the same question, would you rather be paid y equals x squared, or would you rather be paid 1/2 times x squared like that? Yeah, you'd rather be paid that. So what happens if I do, let's say, 0.5, which is 1/2? Duh. Fatter, see? Right? What if I make it like 0.0? Oh, that's very, you see it's going slower. Right? You don't want to be paid that, right? You have to be paid this. How about you get another 0 there? See what happens. Whoa! You see? So it's going to make it fatter. Let's make it 2.5, right? Is that 0.25? Oh, look at this. It's going to do, okay. 5? 2.5. Right? I'm going to put 0 here. Whoa! Okay, see that? Okay. So if you put the number in front of it, that's going to decrease this. It's going to make it fatter. If it's a bigger number, it's going to go up faster. Let's see if I put a F9 there. See? Okay. So now, look. This is the parent graph, y equals x squared. From this, we appreciate how this is going to look. If the number is negative here, it's going to flip the graph. This is y equals x squared. This is y equals negative x squared. Right? And then we learn y equals 5x squared. Well, if this is the parent graph, the 5x squared is going to go faster like this. And if it's a smaller number, it's going to be like a little fatter, so to speak. Do you understand? And we also learned this, y equals x squared plus 5, for example. It's going to be the parent graph, okay, moved up 5 spots, like this. Okay, obviously, these are not accurate representations. We've done that. Clear enough. But look, y equals x squared as the parent graph. The general equation for quadratic functions was y equals ax squared plus bx plus c. The examples I have given you so far, okay, did not have this middle term. Okay? So I give you y equals 5x squared, and I give you y equals negative 5x squared. I give you 5x squared. I give you x squared plus 3, right? But there's no middle term over there, right? What does a middle term do? Well, let's see what happens. So before I do that, I just want to do this one. See, if I do, this is the parent graph. If I put a plus 3, what is it going to do? It's going to move the whole graph up by 3. See, these two graphs, these two are identical graphs. In other words, if you pull this blue graph down over here, it would just fit right on top of the other one nicely. I wish I could almost just bring the whole thing down. I don't know how to do that, but that's just an example. All right, do you understand that? Okay. Now, what if I add a middle term here? Y equals, let's add it to this one, okay? Y equals 3x plus 2. See? The middle term is called horizontal shift. So this term, if it was just y equals this, y equals x squared plus 2, it will just be a vertical shift. If you start adding the middle term like this, you start causing vertical and horizontal shifts, moving this way and that way. So this will be causing like vertical shifts, moving up and down like this. This term will add to the horizontal shift. Okay? How about this? See? Okay? So, see here, there's no third term, see? So, but there's still a vertical and horizontal shift, right? So this term, if it's only there, will add to the vertical shift, but this term is responsible for vertical and horizontal, adding to vertical and horizontal shift. Okay, so now we're going to learn more about that, but listen so far though. Graphing this is pretty easy, right? And graphing this is pretty easy, right? It's going to be just this graph, it will go up faster, right? It will be like this, right? Also, graphing this, I hope, will be easy for you too. Minus x squared. It'll be just flip of this. Graphing this will also be easy for you. It will be the original graph flipped down, right? And skinnier like this. Right? You follow? Oh, yeah. So that's easy, right? And I hope also, if you know how to do this, you can also do this. Correct? I hope also you know how to do this. So the way you graph this function is first, okay, you graph this function, y equals negative x squared, and then you move it up 5. Okay, that would be this graph over here. This is obviously a cartoon representation of it. It's not accurate. Like this. Does that make sense? Now we're going to learn how to graph this function. F of x equals x squared plus 6x plus 3. Okay? F of x equals 6x plus 3. See, to graph any parabola, okay, you need to know where the vertex is, alright? Yeah, it's important to know where the vertex is. Because, you know, if you don't know the vertex, it's going to be hard. Watch this. I'm going to tell you that these 2 points are on the parabola. Graph the parabola. Okay, here's, somebody might say, here's this. Here's the parabola. Okay, nope. That's not the parabola I was thinking about. How about this one? Right? Or how about this one? You see? 2 points are not sufficient to graph a parabola. How many points do you need to graph a parabola? Right? How many points do you need to graph a parabola? How many points, you think? 3. 3. Now, if you have the vertex, it's awesome. Here's the vertex. I'm going to tell you that this is the vertex, okay? That's Vx, Vy. Now, how many parabolas can go through these 3 points? Oh, only one. Can you find any other way? Right? Can you do this? Whoa, what kind of parabola is that? No, right? So there's only one way. So to graph a parabola, you need to have 3 points. And the 3 points don't have, one of them does not even have to be the vertex, actually. For example, how about this point? Right there. How many parabolas can you graph to those 3 points? Yeah? I don't know. First of all, it's going to be U or an N. It's going to be this or like this. It has to be like this, see? So, because these are symmetrical, see? Try to graph a different parabola from this. Let's say this. Well, that's no parabola. You follow? 3 points. You need 3 points. But, you know, if somebody wants you to graph a parabola, one of the most important things that you need to try to find out is where is the vertex? Okay? Where is the vertex? Okay, what's the vertex in other words? So find the vertex, for God's sake, right? Find the vertex. So if the parabola is given in this form, and this is the standard form, that's the standard form. The way to do it is this. You gotta know. This you have to know. It's something new. So the vertex is an ordered pair, and the ordered pair consists of an x-coordinate and a y-coordinate, Vx, Vy. The x-coordinate of the vertex, the y-coordinate of the vertex. Okay. There's a little formula. So this is a formula. So you gotta know this, okay? So this is a formula. This says the x-coordinate of the vertex is opposite of b over 2a. In other words, if you want to find for this parabola the x-coordinate of the vertex, you do this. So watch this. So Vx is going to be opposite of b. What's b over here? 6 over 2 times a. What's a over here? 1. Do you understand? Opposite of b over 2a. That will give you the x-coordinate of the parabola. So that is what? Negative 6 over 2, which is 3. Now this is only the x-coordinate of the parabola. Okay, to plot the vertex, you also have to have the y-coordinate. If you know the x-coordinate, how do you find the y-coordinate? If you know x, how do you find y? You plug it in over there. You plug this in place of x to find the y. Or find the f of x. So what's f of 3? Well, that's going to be 3 squared, substituting 3 for x. 6 times 3 plus 3. 3 squared is 9, plus 6 times 3 is 18, plus 3. Okay? Right? So I'm sorry. This is negative 3. You can correct me. Negative 3. So you substitute negative 3 in the formula. So f of negative 3 is negative 3 squared, which is 9, plus negative 18 plus 3. Okay? This negative 9 plus 3 is negative 6. Get this correctly. Okay? So the vertex, therefore, is negative 3, negative 6. So it's like 1, 2, 3. So that's the vertex, okay? Now look. You follow? Now then you have to decide if this parabola is going to be a U or it's going to be an N type. It's going to be like this type or this type. Now you look at the parent graph. So the parent graph is y equals x squared. If if A here is a positive number, then it's going to look like a U. And if A is a negative number, it's going to like this one, y equals negative k, it's going to look like an N. Over here, since A is a positive one, this graph is going to be a U. It's going to be going like this, right? And the axis of symmetry, what's the axis of symmetry? Yeah? Axis of symmetry, it's going to be symmetrical. This graph is going to be symmetrical, right? Half of this is going to be on one side, and the other half is going to be on the other side. Here's the axis of symmetry, okay? So this is the vertex, okay? So that's the axis of symmetry. The equation for the axis of symmetry, by the way, is x is equal to -3. That's the axis of symmetry. Now we need 2 more points to graph a parabola, right? Oh, where are those 2 points? So we need to find 2 more points to graph a parabola. Well, how are we going to get them? I don't know. It's not like we have the equation of the parabola, so you can plug in some numbers, find a uh, uh, y or something like that. Wait a minute. We are given the equation of functions. I can plug something in and find points, right? Yeah, let's plug in. I don't know. What should we plug in? Well, let's plug in 0 for x. Well, so what's the value of y when x is 0? See, when x is 0, what's y? You plug in 0 over here, y is 3, right? Oh, here's 1 point. X is 0, y is 3. Oh, I got one more point here. Well, I need another point. Well, it's going to be symmetrical, right? So there's going to be another point right over here. Yeah, right there. Is that enough? Yeah, you only need 3 points. You can get more points if you want to look pretty or something like that. But you only need those 3 points over there, and you can draw that graph. Do you understand? So this is a graph of y equals x squared plus 6x plus 3. Okay, so let's do that. Let's try to graph this. Y equals x squared plus 6x plus 3. See? Like that. Vertex, -3, -6, 0, 3. Understand? And then let me just tell you for axis of, what's the equation for the axis of symmetry here? Yeah? The equation for the axis of symmetry would be x, it's a vertical line. Vertical lines have x equals something equation. X equals -3. It's going to go right through the vertex right there. Right? So the equation for the axis of symmetry. So this is a parabola. It's a quadratic function. Okay? So, I told you that this is a quadratic function. Okay? And the way you graph this quadratic function is by first finding the x-coordinate of the vertex by this. And then once you find the vx, and you substitute this back into the equation to find the vy. And once you have the vertex, you plot the vertex, right? You know the axis of symmetry. You just get another point somewhere, right? Another 2 points, and then you graph the parabola like this. Okay? That's how you do it. So let's do another example, shall we? How about this one? Let's call this g of x. Okay? Minus 2x squared plus 8x plus 3. Okay, fair enough. Let's see how that looks like. Well, this is in the standard form, so we know that we have to find the vx first, the x-coordinate of the vertex, and that's given by opposite of b over 2a. Look at this. I'm being such a good boy. I'm trying to find this. I'm writing the equation every single time, right? Even though I've probably written this how hundreds of times already. So, but it's important. So this is like mathematical good manners to show your work, right? It's important. It's also very important to try to have a good handwriting so it didn't give your teacher a headache when you write this stuff and she has to go here, she has to grade your test. I mean, come on, like, she's got a life, or he's got a life. So do your teachers a favor, for God's sake, and have a good handwriting, okay? There's some simple kindnesses you can do, to other people. So opposite of 0 2a. So negative 8 over 2 times a here. So a is negative 2. B is 8, right? A is negative 2. Again, watch this. Y equals ax squared plus bx plus c, standard form. A is negative 2, B is 8, C is 3. So opposite of B over 2a, negative 8 over 2a, okay? This is going to be 2. And 8 divided by 4. Alright, now we find the Vx. Now, how do you find the Vy? Oh, well, you substitute the x value in the y over here. Yes, you substitute that. So you find, what's g of 2? You get negative 2 times 2 squared plus 8 times 2 is 16 plus 3. So that's 4, right? 4 times 2 is negative 8 plus 16 plus 3. That's 8. That's 11. So that's the Vy. So the vertex, therefore, is 2 and 11. So now that you know the vertex, you can graph the parabola. Alrighty, so here's 1 and 2. And here's approximately close enough to 11. That's the vertex. Now, is this graph going to be a U or an N? Yes, it's going to be an N because it's negative. And A is negative, the parent graph is going to be like this. Right? It's going to be an N. So this is going to look like kind of like this, okay? Okay, so now, once you have the vertex, okay, here's another theory you can do to your teacher. You draw the axis of symmetry. If you draw it neatly, they might really appreciate it immensely. You don't have to make it like this. Usually, typically, you can make axis of symmetry a dotted line, okay? It's harder to make a dotted line. So you make it a dotted line. That's the axis of symmetry. And what's the equation for the axis of symmetry? Here. X equals to 11? No. X equals 2. That's the axis of symmetry. So this is going to be n. So we need another point, right? We need 2 more points. One on this side, one on this side. Well, I wonder why if I plug in 0 for x, right? It's a good one to do, right? When I plug in 0 for x over here, okay? When I plug in, okay, 0 for x, I get, this cancels out, you get 3. It's right over here. Okay? So right here. And then on this side, this is 2, can be 4 and 3, right? You see? That's 3. 0, 3. This is 2 removed from the axis of symmetry, so this is going to be 4, 3. And this graph is going to look like, okay, this is like, impressionist for parabola. See that? Let's do this. Negative 2x squared plus 8x. Y equals negative 2x squared plus 8x plus 3. See? That's the parabola that we drew. Okay? So that's how you draw these parabolas. Now, just as a review, the general formula for a parabola is this. Okay? Parabolas are quadratic functions, right? And the way you graph this is by finding first the vertex. Okay? And from here, you find the y, first you find the x coordinate of the vertex and then the y. And then you have both the Vx and Vy, and then you can plot this. You have the axis of symmetry, and then you need 2 more points, one on each side of the axis of symmetry. You're done. Now, I have said this is not the only way to write an equation of a parabola. Okay? There are 2 other ways that we're going to familiarize ourselves with. Okay? But not today. I'm going to do that until next time, so I don't overwhelm you. The second way, however, I'm just going to introduce you. The second way of writing parabolas is y equals f of x, or y equals, okay, a times x minus vx squared plus vy. Okay, this is called the vertex form. Alright, this is called the vertex form. Right? And then there's a third way, and that's called f of x equals a times x minus s1 times x minus s2. Okay, this is called the X Intercept Form. Okay, so these are 3 ways of writing parabolas. Inshallah, next time I shall explore this one, and this one I shall review this one. But I'd like you to do this. Okay, you should be familiar, comfortable with these. Okay, and then so just write this out. Okay, write them out like 5 times or something like that. And then so you're familiar with these terminologies, and once we go over them, you are somewhat comfortable with them, and then learning them would be inshallah much easier. Until next time then inshallah. Assalatu wassalamu ala rasulillah walhamdulillahi rabbil alamin.